Everyone in the chip world argues about the same three names. ASML, who builds the machines that print advanced chips. TSMC, who runs the fabs. NVIDIA, who designs the chips that train AI. But there's a fourth company, a Japanese one, that sits quietly upstream of all of them, and almost nobody talks about it. Here's the claim. No chip below 5 nanometers can ship unless its photomask passes one final test. And the only machine on Earth that can run that test is made by a single company, Lasertec. More than 90% of all EUV mask inspection runs through it. For the most advanced masks, its share is effectively 100%. This is one of the most concentrated choke points in the entire AI supply chain. And today we pull it apart. To see why, you have to understand what a photomask is. A modern chip is built by shining light through a mask, a quartz stencil holding the pattern for one layer of the circuit. That pattern gets projected, shrunk, onto the wafer over and over, so if there's a single defect on the mask, it doesn't ruin one chip. It repeats on every chip, on every wafer, for the entire life of that mask. The mask has to be perfect. Now add EUV, extreme ultraviolet light, with a wavelength of just 13.5 nanometers. It's the light that prints everything at 5 nanometers and below. And here's the problem. The defects on an EUV mask are so small that the only way to see them, the way the scanner will, is to inspect using the exact same 13.5 nanometer light. The industry calls this actinic inspection. An actinic mask inspection is a club with exactly one member. Lasertec's ACTIS A150 is the only commercial actinic EUV mask inspection system that exists. 4 things make that monopoly almost unbreakable. Let's take them one at a time. First, the physics that locks everyone else out. There are other ways to inspect a mask. You can use a 193 nanometer optical tool or an electron beam. KLA, the giant of chip inspection, dominates exactly those approaches, but neither one sees the mask the way EUV light does. A defect that looks harmless at 193 nanometers can still print a fatal flaw at 13.5. Only actinic inspection, the same wavelength as the scanner, tells you what will actually end up on the wafer. That's not a feature you can bolt on. It means building a tool with its own miniature EUV light source. The same brutally hard technology that makes the scanners themselves cost hundreds of millions of dollars. Lasertec spent years in enormous research budgets getting there first, qualified inside real fabs with real customers. The ACTIS A150 is the result, and a single unit sells for more than $75 million. For the most advanced masks, 5 nanometers and below, Lasertec's share is essentially total. KLA is a far bigger company and still the leader in broad wafer and mask inspection. But in actinic EUV mask inspection, the one test no leading-edge mask can skip, there is no second supplier. Second, what that monopoly does to the financials, because the numbers are almost unreal. In its most recent fiscal year, Lasertec did about 251 billion yen in sales and turned roughly half of it into operating profit. The operating margin was 48.8%. Return on equity was 46.9%. To put that in perspective, an ROE above 30% is already considered extraordinary. Lasertec is sitting near 47, a number you almost never see in heavy industrial equipment. How? Partly because Lasertec is effectively fabless itself. It concentrates on the research, the design, and the customer relationships, and outsources much of the actual manufacturing. But mostly it's pricing power. When you're the only door a product can pass through, you don't compete on price, you set it. This is what an invisible toll booth looks like. Every advanced photomask in the world, for every leading-edge chip, every AI accelerator, every flagship phone processor, has to be checked on a Lasertec machine before it can go into volume production. And every one of those checks, directly or indirectly, pays a toll to the same company in Yokohama. Third, the demand curve, which is bending the right way for Lasertec at exactly the wrong time for everyone who depends on it. Every major AI accelerator shipping today, the GPUs training the big models, the custom chips inside the hyperscalers, is built on an EUV node, More AI demand means more advanced chips, which means more new mask designs, which means more inspection. Lasertec has actually raised its order outlook on the back of AI, and its backlog now stretches well over a year. Then there's the next step. High-NA EUV, the newer, even more extreme machines that Intel and TSMC are bringing online for the nodes after this one. Every high-NA layer needs its mask qualified all over again. More inspection cycles on harder masks. And Lasertec is already co-developing its next-generation actinic system for that era, reportedly alongside TSMC, Samsung, and the research institute IMEC. So the moat isn't just holding. The AI boom and the move to high-NA are actively widening it. The more advanced the industry gets, the more indispensable that one machine becomes. Fourth, and this is where the story turns. Lasertec is a Japanese company, part of a quiet cluster of Japanese firms, in materials, in equipment, in precision optics, that the whole leading edge runs on. That's a real strategic position. Part of why a small company in Yokohama can hold the entire industry by a single bottleneck. But that same position hides its biggest weakness. Think about who actually buys an actinic EUV mask inspection tool. You need to be running EUV lithography at the leading edge. And on the entire planet, that's 3 companies: TSMC, Samsung, and Intel. That's the whole customer list. So Lasertec's monopoly is real. But it's a monopoly selling to an oligopoly. When those 3 are expanding capacity, orders pour in. When any of them pauses EUV spending or pushes a fab out by a year, Lasertec feels it immediately. The revenue is lumpy, cyclical, and concentrated in a way almost no other monopoly is. The toll booth is real. It just sits on a road with only 3 drivers. So how should you think about Lasertec? Start with what's not in dispute. The technical monopoly is real, the actinic moat is real, and the margins are extraordinary. If you wanted one picture of how concentrated the AI supply chain has become, it's hard to beat. One Japanese company, one machine, and a test no advanced chip can skip. But real is not the same as risk-free, and 2 cautions are worth saying out loud. The first is concentration, a monopoly that sells to just 3 customers' lives and dies by their capital spending. The second is that Lasertec has been challenged directly. In June of 2024, the short seller Scorpion Capital published a long report accusing the company of overstating its technology and its accounting, even calling its flagship tool defective. Lasertec denied it, and an internal investigation found no irregularities. But the stock still fell hard, from above 40,000 yen to around 15,000 within a year. The market priced in real doubt. So the honest verdict: Lasertec owns the purest choke point in the chip industry, a genuine physics-backed monopoly, but a concentrated, cyclical, and closely scrutinized one. The machine is indispensable. The stock is not the same thing as the machine, and whoever inspects every advanced chip on Earth is worth understanding either way. If you found this useful, subscribe. This channel digs into the companies and choke points the headlines skip. The actual semiconductor industry view, one bottleneck at a time. The deeper you go into the AI supply chain, the more you find these quiet monopolies holding everything up. Lasertec is one of the purest there is. Thanks for watching, and keep an eye on the machines nobody talks about.